I'm talking about Internet of Things. Here, first, the term Internet. As you all people know, you people have studied computer networks. Any two devices or more than two devices, when they are getting connected for communication purpose, okay, they form a network. Okay, so we have a internet and we have a things. Things are smart objects. When I am talking about objects here, what the objects contain? The objects contain the Wi-Fi modules. The whatever the Wi-Fi module is present in the objects, these are being utilized for communication purpose. So nowadays, whatever the objects which are being connected, these are smart objects, and these objects are required for exchange of data, that is transfer of data. Okay, so this is one most important point you have to remember. In a previous classes, I have given a lot of examples regarding the smart objects. So nowadays there is a concept of smart homes. In a smart homes, whatever the objects which are being present, these objects are smarter. Okay, so this is one of the most important point you have to remember. So whatever the refrigerator is there, whatever the television is there, okay, the door, okay, these are all being uh, smarter. Okay, so the door lock, you can just being used by just giving a command, a voice command. If you give, it will automatically lock it. Okay, so you don't have to physically go and open the door. Okay, or just close the door. Okay, you just give the voice command, and accordingly it will do the thing. Okay, so nowadays commercially there are a lot of vendors which are providing you with many of the things. Okay, so one of the most important thing, the most popular one is Amazon's Alexa speaker. The speaker is a smart speaker. When I say Alexa, switch on the lights, okay, in a smart home it will automatically switch on the lights. Okay, so this is a sample example I have given. Not only the Amazon is producing such type of products, you have a Google, the Google's Echo Dot, that is also a smart speaker. And Apple's, you have a lot of smart things which are being utilized. So in mobile also, you can have if you are using Apple mobiles, you have a Siri, okay, which is utilized whatever the voice commands you provide, accordingly it will act. Okay, so these are the things which we people have discussed in the last class. We have taken a look at a brief overview of the history of the Internet of Things. The one who made it, okay, that's the Kevin Aston, who coined the term Internet of Things. Okay, so we have talked about the radio frequency. So radio frequency identification. So for this one, I have given a sample example of a forest department. If a forest department want to track certain wild animals which are endangered species, then they will use a tracker ID, that is the radio frequency identification. Accordingly, they will track that particular endangered species. Okay, usually they will use it on tigers. Okay, that's the endangered species, you can say, because the tiger population is drastically decreasing, and it's a government initiative to increase the population of tigers. Okay, this is just a sample example I have given. Okay. Then we people have discussed regarding how IoT works, communication and cooperation. Okay. So whatever the things, there are tiny things. Okay. It's not the thing that the size should be bigger and bigger. Okay. It's a very tiny thing, and that is being utilized for communication purpose. You have addressability, you have identification, you have a sensing. Sensors are present, activators are present, embedded information processing, localization, and user interfaces. So these are the uh, important points you have to remember. Then we people have discussed regarding identification and tracking of the data. This is one important point. Then we people have discussed regarding the collection and processing of the data. That is another one important point. Okay, so to enhance the power of the network, devolving a processing capabilities to different part of the network. This is one important point. And another one, to make the smaller and smaller things have the ability to connect. So that is what I was speaking about. You have a very tiny objects, and the tiny objects are involved in communication purpose. So for this, I will give one sample example of smart farming. In smart farming, you have a tiny objects, and these objects are being utilized for monitoring the temperature, the humidity. Accordingly, it will impact the productivity of the agriculture. Okay, so this is one important point you have to remember. Next, we will take a look at characteristics of the internet of a thing. Here, when I am talking about the characteristics of internet of a thing, one is intelligence. Okay, another one is connectivity. The third one is a dynamic nature. The fourth one is scalability, sensing, heterogeneity, and security. These are important characteristics you have to remember. It can be a 4 marks question in your external examination. You should be in a position to list out and discuss the characteristics of Internet of Things. Okay, so this is one important point. Then again, uh, let us take a look at challenges. Whenever new technologies come, there will always be challenges, and accordingly, certain solutions need to be found. Okay, so this is one most important thing you have to remember. Okay, so scalability. When we are talking about a scalability, okay, you have a billions of devices which are being connected. Okay, when the days gets passed, okay, billions of devices will be added to the network. Okay, so uh, for this, I can give one sample illustrative example. So IPv4 to IPv6, the transition IPv4 to IPv6 has been occurred. Okay, so this is one most important point which you have to remember. Okay, uh, so scalability is an challenge. Okay, so as the number of devices, as the number of smart things go on adding, it will be a problem because the growth of the network, okay, the network will become very large. Okay, another one is the technological standardization. Okay, compatibility issues. If you want to avoid, then you require certain rules and regulations, certain frameworks. That is all about your standardization. Interoperability, okay, it should also be possible to connect to the legacy systems. Discovery, okay, so in an environment in which you are deploying the things, okay, it need to be discovered. Okay, that is one important challenge. Okay, and environment also changes. That is one important thing. You have a software complexity. You have a data volumes and interpretation. Okay, as I am talking about, you have a huge data which is being generated, and it will be stored in a cloud. Not only the storage of the data will present, the analysis of that data will be one of the most important factor, you can say. So that is one challenge, you can say. Okay, if I want to give one sample example, the jet planes have lakhs of sensors. Each of the sensors will be monitoring and collecting terabytes, you can say, or a gigabytes of a data within a span of hour. Okay, such a huge data, when it is being generated, it will be stored in a cloud. Okay, so that is one important point which you have to remember. Power supply, it is one constraint, you can say. Okay, it's usually a battery powered. and it is a constraint. Okay, the battery drainage is a issue that need to be resolved. You have an interaction at a short range communication. That is one important point. You have a wireless communication. You have a fault tolerance. So these are some important challenges which you have to remember. Next point. So let us take a look at another one thing. Wait a minute. So Saida, am I audible to you? Can you unmute and reply to me? So Saida, just unmute yourself and just acknowledge me so that I can continue. Am I audible to you? Just acknowledge me. The challenges of Internet of Things, whatever the points which I have discussed, are the points clear to you? Acknowledge me so that I can continue. If there is some network issue, you can always point it out so that I can resume the things once again. Or else you can use always a chat box also. You can write down in the chat box if you have any doubts. You can always. So just acknowledge me. Is it audible so that I can,
Yes, sir.
if there is, okay, it is audible, fine. So what will happen because of some network issue? If I am going on and you are not receiving at that end, then whatever I say, everything will be vanished. For that purpose, in a 15 to 20 minutes, I will be asking for acknowledgement. So let us take a look at the next slide, the criticism. The criticism and controversies of Internet of Things. So privacy is the biggest concern here. Okay, when I am talking about deploying of Internet of Things, privacy is the biggest issue. Okay, in European countries, policies have been made for that purpose. Okay, so whatever the IoT devices which are being deployed in a smart homes, okay, when you are taking a look at that one, okay, privacy is the biggest concern. Okay, because 24/7, whatever the IP cameras are there, they will be collecting the data, and it is the biggest concern because whatever the hackers are there, they will be penetrating the system, and if the security is not of that level, it will be penetrated, and whatever the data, whatever the streaming is there, it will be captured without your consent. So that is one biggest point you have to remember. Another one thing is autonomy and control, the social control, the political manipulations, the design. You have environmental impact and influence human moral decision making. So these are the controversies which need to be resolved as soon as possible. Okay, next we will be taking a look at one important point, that is the security. Security is the biggest concern. Okay, when you are talking about a security, the level of security which is being applied, it matters a lot. Okay, am I audible? Acknowledge me.
Yes, sir.
Okay, fine. Whatever the PPT is, I have shared with you. Is it visible?
Yes, sir.
Can you read the heading of the PPT?
The Internet of Things security consideration for higher.
Okay, fine. Okay. Uh, okay. Now the pictures are there. Very interesting pictures are there. We will be taking a look at one by one the pictures and what they mean. One is a wearable tech. You people are already using it, the fitness band. Okay. What the fitness band do? It will always monitor. It will always capture your heartbeat rate, the step counts. Okay. So uh, the commercially available fitness bands. Okay, the most popular one. You have a Samsung Galaxy smartwatch. Okay, you have a Apple's smartwatch. Okay, you have Xiaomi's My Smart Band. Okay, and also the smartwatch. Okay, what these things will be doing? They are wearable devices. They have embedded sensors. They are IoT devices. They are smart objects. What they are doing? They are continuously monitoring. And when they are monitoring, you can say some amount of battery drainage will occur. Okay, that is a limitation. That is a challenge. What you will do if the battery gets completely drained? You have to charge it once again. Okay, then again you can use it. Okay, so these are the limitations you can say. Okay, so fitness band, smartwatches, these are all the IoT devices for monitoring, capturing, collecting the data. Okay, the health related data it will be. Okay, when I am talking health related data, whatever exercise, whatever the exercise you are doing. Okay, if you are sprinting, if you are walking, if you are swimming, whatever activities you are doing, how much calories are burnt, all the things will be recorded and stored in the cloud. Okay, so that is one important thing which you have to remember. The healthcare sectors, in healthcare sectors also, it plays a very pivotal role. Okay, when I am talking about a healthcare sector, okay, uh, here you are having numerous IoT devices which will be constantly monitoring. Okay, and another one sample example which I want to give is a pacemaker. The pacemaker always will be monitoring the condition of the heart, and accordingly it will give the notifications. Okay, so this is just a sample illustrative example which I have discussed. Here at the right end, the diagram of a refrigerator is being shown. It is not just a normal refrigerator, but it is a smart refrigerator. When I say it as a smart refrigerator, whatever the grocery, whatever the vegetables you are uh, keeping inside, okay, everything it will be monitored. And whatever the milk packets you are keeping, okay, it will be monitoring it continuously. If, for example, say there is no vegetables in that smart refrigerator, it will give a notification. Yes, you need to buy vegetables for the next day. Everything is empty. In this way, certain notifications will be given to your smartphone. Okay, so that you can know it. And when you get a notification, you can directly buy online whatever the vegetables you want. Okay, everything they have automated. There is no physical activity. Okay, so this is just a illustrative example. Let us take a look at another one example. So this one is a machine to machine world of connected services. When I am talking about a machine to machine, what does it mean? Okay, when you are interacting, okay, human to machine, okay, it will be H2M, okay, human to machine, okay. So example of that one, you can give as a wearable tech, the fitness band, okay, it is a human to machine, okay. In other way, you have machine to machine interaction also, that is also being present. Machine to human is also present, that is called as a M to H, okay. And H to M, okay, that is human to machine, okay. It can be human to machine, it can be machine to machine, or it can be machine to human, okay, etc. Okay, so this is just a sample illustrative example for understanding purpose. And let us take a look at the smart internet of things school. When I am talking about this, okay, whatever the education institutes are there, they are being smarter, okay. Whatever the school is there, they have completely become smarter. Whatever the notifications will be there, it will come to your smartphones, and accordingly you can act, okay. So this is one thing. Let us take a look at the internet of things market. As I told you, billions of devices will be added. That is one illustrative example you can have. And later on, here you can talk about the expected growth. Okay, when the time passes, accordingly, the number of devices also grows. Okay, that is one thing. And the revenue growth is in a trillions. That is also of the survey is being made in the year 2013. You can imagine how will be the things now. Okay, so this is one illustrative example. Let us take a look at the next slide. So, what's the concern when you are talking about the Internet of Things? Here, as I told you, security is one of the important issue that need to be taken into account. All of the same issue we have with access control. Vulnerability, when I am talking about the vulnerability, that is the weaknesses. Okay. Whenever there are weaknesses, the hackers, the penetration testers penetrate the system. Unauthorized access of the data, stealing of the data will occur. Imagine your network with this much number of devices. It is a very huge thing. Okay, in a real time, the things will be very different. Okay, that is one important point you have to remember. Okay, another one thing. Let us take a look at this thing. Wait a minute. I will move on to the next slide. Okay, this is the next slide. When I am talking about this one, are highly portable devices captured during a vulnerability scan. That is one additional risk you can say. Okay, the perimeter of a network also matters. That is another one risk you can say. Consumer devices being used in areas like healthcare, where reliability is critical. Okay, accuracy of a data matters a lot. If the data is being altered, then again it is a threat. Okay, this is one thing. Do users install a device management software on other computers? Okay, that is also one. If you are using a third party software which is being installed and it is not from a trusted source, then again it is a threat. Let us take a look at the architecture. This figure is important. Again, I'm repeating, this figure is important. You can expect a question in external examination regarding the IoT architecture. A very high priority question may be asked for a 6 marks. What you can see here is a sensors. Some sample sensors they have been shown. The temperature sensor, the humidity sensor. You have a pressure sensor. You also have a motion sensor. Okay, these are a few sensors which is being shown in a figure. You have Internet of Things, a gateway, the gateway and the framework, the wireless communication, the cloud servers. Okay, whatever the things which is being collected will be stored in the cloud. Okay, so this is one thing. And then here you have a mobile app by which you will get the notifications. This is a very simple illustrative figure of IoT architecture. Okay, the radio frequency IDs, I have given a sample illustrative example of a forest department. when they want to track the endangered species like a tiger population, they will use a RFID tag on each of the tigers. It will keep track of the geological location. Okay, whatever the uh, latitude and longitude, the exact position of that particular uh, uh, wild animal is there. Accordingly, it will keep track of if it is moving from one forest to another forest with precision. It will be taken track of. Okay, that is one important point which you have to remember. Okay, fine. Readers are plugged to a local computing system which read the EPC, a local system offering a internet protocol connectivity that collects the information positioned by the EPC, a protocol called object naming service. So what is EPC is it is just a electronic product code. It is a electronic product code. One code will be given. Okay, so they have introduced it. Okay, uh, so this is just the importance of uh, guidelines and policies and practices, the framework. Okay, so the global consortium has introduced that one. Okay, and they have specifically talked about operating in the 860 and 960 megahertz frequency band. Okay, that is one interesting thing which you have to remember. Okay, the extended markup language documents are carrying a meaningful information linked to the radio frequency IDs. Then we will be taking a look at the Internet of Things data collection and management centers located in the network's core, possibly even in a distributed cloud. The IoT operates in a conjunction with a real-time processing and ubiquitous computing. So that is the specialty of Internet of Things. When pursued as a global network, it will connect the physical objects with virtual objects through the combination of the data capture techniques and communication networks. So let us take a look at another one terminology, the low end of spectrum. The things information is typically coded by the unique identification and or electronic product code EPC. The information is typically stored in the radio frequency identification RFID electronic tag. The frequency is uploaded by non-contact reading using a radio frequency identification reader. So UID and the RFID have been mandated by the Department of Defense. So you can just take a look at the DOD, that is the Department of Defense. It has mandatorily made compulsory regarding the use of user identification and a radio frequency tags. Okay, uh, the suppliers must okay to modernize their global supply chain. These are being mandated for. Okay, then let us take a look at mid range of a spectrum. Devices with embedded intelligence, the microprocessors. So whatever the microprocessors are there, okay, that are being used in the smart objects, they are being embedded. Okay, they contain the wireless capabilities to perform a variety of the gathering of data and possibly control the functions on body, biomedical sensor, home appliances, and power management and industrial control of examples. So that is one important point. At the other end of the spectrum, more sophisticated sensors can also be employed in the Internet of Things. Some of these sensor approaches use distributed wireless sensor networks. So WSN, it is just an abbreviation of wireless sensor networks. Wireless sensor networks, the network comprises of smart objects. The objects have embedded in them the sensors. Okay, whatever the sensors which are being deployed in the environment, they will be continuously monitoring the environment and they will be collecting the data. Okay, that is one important thing that you have to remember. Okay, so that can collect a wide variety of the environmental data such as a temperature, atmospheric and environmental chemical content, or even a low or high resolution ambient video images from a geographical dispersed location. Okay, so this is one important point which you have to remember. It can be a 6 marks question for your external examination. Can optionally pre-process some of or all of the data can forward all these information to a centralized or a distributed site for advanced processing. These objects may span a city, region, or a large distribution grid. Other things may be associated with a personal area networks, that is a PANs. Okay, it is an abbreviation for personal area networks. Vehicular networks are being abbreviated as a VNs, or delay tolerant networks are being abbreviated as a DTNs. That is a delay tolerant networks. Okay, fine. Then we will be talking about a high level logical partitioning of the interaction space. The high level logical partitioning of the interaction space, showing where the Internet of Things apply. As I told you, H2M, human to human interaction. Okay, that is a communication. Okay, another one thing is a M2M, that is a machine to machine communication. You have a H2M, that is human to machine communication. You have a MIH also. Okay, MIH communication, that are the embedded chips, medical monitoring probes, as I give an example of a pace maker, which will be uh, embedded. Okay, at the time of heart surgery. Okay, the person who is suffering from heart failures. Okay, a pacemaker will be utilized. A surgery will be done. After a surgery, okay, they will keep track of the monitoring the whatever the heartbeat rate is there, and accordingly they will analyze the data, and accordingly they will diagnose. Okay, so that is one illustrative example of a MIH communication. Okay, so you have a global positioning system bracelets, that are the GPS bracelets, and etc. so on. Okay, this is a figure. This is very important. A 6 to 8 marks question you can expect in internal and external also. Okay, you can tell to your friends also, 100%. Okay, so this is very very important. You have to draw the Venn diagrams. Okay, circles if you draw, and you mention the human to human communication, the machine to machine communication, the intersection, the conjunction, all those things. Okay, this is a Venn diagram. You can easily practice it for 5 times, 10 times. You can easily draw this particular figure. Okay, so this is one thing, human to human interaction, a machine to human interaction. Okay, so this is one diagram which will come in your external examinations. Okay, let us take a look at another one picture. This too shows you the traditional electronic communications and the Internet of Things. The traditional electronic communications and the Internet of Things. You have to practice it. 6 marks to 8 marks question you can expect. This shows illustrative example of the Internet of Things. You can see the weather server, the traffic server, the medical server, the police radio server, the pollution data aggregation. Okay, and the caregiver, physician. Okay, all these things. Okay, that is a mesh. It is a network. Okay, the devices are being interconnected to each other. Okay, fine. So this particular figure, yet another illustrative example of the Internet of Things, body area network. You can see at the right end a picture of the human being is being shown. Okay, whatever the things, the pace maker, all those things, the MIH being embedded. Okay, the electronic chip which is being embedded, that is being continuously monitoring the health related data, and it will be uh, communicated. The data which is being collected, it will be stored in the cloud itself. Okay, thus the doctors can diagnose it properly. Okay, this is one thing. You have a medical server, you have a caregiver physician. Okay, that is being connected to the internet, that in turn is being connected to the home network. Okay, this is just a illustrative example how exactly the things will work. Okay, regarding the IPv6 role. Okay, as I told you, whatever the IPv4, it is being used for addressing. In a similar fashion, IPv6 is also used for addressing. But the thing is, billions of devices are being added. Whatever the billions of devices which are being added, these require a large number of addressing. Thus, IPv6 addressing is being required. Okay, this is one thing. So IPv6 with its abundant address spaces, globally unique object thing, identification, and connectivity can be provided in a standardized manner without additional status or address reprocessing. So regarding the IPv6, it is a 128-bit addresses when you are comparing it with a 32-bit IPv4. The objects can be tagged with a network address. Every object then has a tuple object identifier, the network address that is always unique, although the second entry of the tuple may change with a time, location, or a situation. Okay, so this is very important. You can expect a 6 marks question regarding this particular thing. Regarding the IPv6 supports more secure name resolution, the neighbor discovery send protocol capable of running a cryptographic confirmations. So object identifier is being present for identification purpose. You can uniquely identify that particular object with the OID. Okay. The plug and play, the IPv6 includes a plug and play mechanism that facilitates the connection of equipment to the network. The requisite configuration is automatic mechanism. Next, wait a minute. Okay, security, as I told you, it is one of the challenges which will be faced. Another one thing is mobility. That is another one important point. The IPv6 will make man in the middle attacks. That is a threat. And he already has studied it in a cryptograph. The man in the middle attack, also called as the monkey. Okay, one of the interesting point regarding that, and also funny. Okay, scalability. IPv6 allows to connect trillions of the Internet of Things devices. Internet protocol capability, multicasting capability. Let us take a look at the next slide. Wait a minute. Okay, this is a pictorial representation. Here you can see the weather server, the traffic server, the medical server. You have a caregiver physician, the police video server, the pollution data aggregation. These are all being aggregated and connected to a network that is a correspondent node, and in turn you can access it by your home network or a foreign network. The abbreviations being utilized are the BU, MN, and CN. BU stands for binding updates, MN stands for mobile node, and CN stands for a correspondent node. Okay. Technical challenges. When I'm talking about the technical challenges, the current manner of using IP addresses must change to a system that provides an internet protocol address to every possible object that may need. The power behind the embedded chips on such devices will need to be smaller and more efficient. That is one important challenge, you can say. The software application must be developed that can communicate with manage the stream of the data from hundreds of interconnected non-computing devices that comprise a smart system which can adapt and respond to the changes. This is the another one, a challenge that is being faced and need to be resolved. Let us take a look at machine-to-machine communication, being abbreviated as a M2M communication. The machine-to-machine communication, it describes devices that are connected to the internet using a variety of fixed and wireless network. Okay, it can either go for a fixed, okay, that is a wired connection. It can go for a wireless connection also. And when we are using that connection, it is used for communication purpose, communication with each other and wider world. There are active communication devices. The term embedded wireless has been coined for a variety of application where wireless cellular communication is used to connect any device that is not a phone. This term is widely used by the GSM Association. Okay, so this is one thing which you have to remember when you are talking about the machine-to-machine communication, M2M communication. Okay, this can be a 6 marks question in your external. You have to put a lot of efforts for this particular topic. It is a frequently asked question, and you can expect this question in the internal also. Okay, I will be giving it. Okay, so some see machine to machine deployments into 4 domains, that is sensors and controllers, that's where data from these devices are gathered in the cloud, where the data are stored and managed at the client, where the data are ultimately evaluated. EBC, information services servers that process incoming ONS request and return a physical markup language PML files. Okay, so let us take a look the continuation part. The technology for sensing and control includes electric and magnetic field sensors, radio frequency sensors, optical, electro-optic, infrared sensor, radar, lasers, location navigation sensor, seismic and pressure wave sensor, environmental parameter sensors. So these are all the things, the sensors which perform a specific operation. Then let us take a look at another one point. You have a sensor networks which usually consider the remote devices are belonging to two classes based on device capabilities, belonging to two classes based on device capabilities. One is a full function devices, FFDs, and a reduced function devices, that is RFDs. Sensors and activators are part of a large universe of objects. Objects in the Internet of Things context can also be classified from the functionality perspective. Okay, so regarding the activators, you already people know when you were in 8th semester. Okay, you people have discussed regarding the sensors and activators. Let us take a brief overview of activators. An activator, it is just a mechanized device. Okay, so remember that particular thing, and much more regarding these things we will discuss in next class. Saida, can you unmute yourself and tell me whatever the things I told you, is it easy to understand for you people? Saida?
Yes, yes, sir.
Okay. So on 4th of April, you have internals, no? Is it?
Yes,
Okay. The syllabus is first module full and 75% second module. Okay.
okay,
Refer
sir.
previous year question paper. Refer what
Sir.
video resource, visit video resource, download 2-3 previous year question papers. It is worth, if you prepare it with a dedication, really you can score 80 marks, 80 plus marks. You have to put a lot of efforts, you can do it. Okay, and tell
Okay,
to
sir.
your friends also, if they are referring the previous year question paper, no, their external will be easy. Okay, if they put efforts now at this moment, their external examination will be easy. Okay,
Okay.
if you want to ask something to me, you are welcome. Saida, any questions?
No, sir.
Okay, then I will conclude today's class. Can I?
Yes, sir.
Okay, fine. So thank you for attending today's session. We will see you in next class. Thank you one and all.
Thank you, sir.